right, let's get our notes out. Section 4, chapter 4, section 1. And let's get some basic vocabulary figured out. Okay. This is not the lunch period, is it? No. Good. We'll have uninterrupted time together. All right. Oh, I need to take attendance too. Let's do this first problem here. All right. Anybody know the definition of an angle? The definition of an angle. Okay. Close. You're on the right track. It's the union of two rays with a common endpoint. Does that make sense to you? Two rays that have a common endpoint. That common endpoint is called the what? What do we call this guy right here? Vertex. And if our angle is rotating in this direction, like I have the arrow marked there, this is called the initial side. That's where we start. And then this is called the terminal side. That's where we end. Every angle that we do, with one exception, every angle that we do will be in standard position. Standard position means your vertex is at the origin and your initial side is the positive x-axis. So when you draw an angle, you're going to draw it with a vertex here and starting here. So if I wanted to draw 60 degrees, it would look like this. That's standard position. Vertex at the origin, initial side is the positive x-axis. And that's where we start measuring from, okay? Every time, with one exception, which we'll talk about when we get to it. This angle, I measured in degrees. And for us, where we are right now at this moment, that makes perfectly good sense because it's probably the only way you've ever measured angles. Think back in geometry with your little protractor, weren't you measuring in degrees? Like 40 degrees and 180 degrees and whatever. There are other ways to measure angles. This class, pre-calculus, is like the end of the degree time and the beginning of the radian time. From now on, in your calculus and any other math classes you take, your angles will be measured in radians. Now, before you get confused, I want you to stop and think a minute. If I told Peter to measure this desk, could he measure it in feet? Mm-hmm. Yep. Could he also measure it in meters? So we are used to having more than one way to measure things. So now our angles are going to be measured in what's called a radian. Here is what a radian is. If you draw a circle, and let's say that circle has a radius of 5, and you take a piece of string that is exactly 5 units long, same as the radius, and you lay it around the circle like this. That is 1 radian. So in other words, a radian is the measure of the angle that determines an arc of radius length. So if your radius was 6, and we had an arc that was 9, can anybody tell me how big that angle would be in radians? 1.5. Exactly. because every radius is a radian. So since this is a whole radius and a half another one, it's the angle's 1.5. A radian is the measure of the angle determined by an arc of radius length. So just to make sure you're getting the hang of it. What if I had a radius of 12 and I had an arc of 6? How big would that angle be right there? Half a radian. Half a radian. Because to get a radian, you would need 12. If you only have 6, then you only got half a radian. In a minute, we're going to be changing back and forth, but first, let's get the rest of this done. Arc length, this is an arc length. I'm not exactly sure how you're going to define it, but I'm going to give you a formula for it. Arc length equals radius times radians. We'll practice that in a minute, but for now, where it says arc length, write radius times radians. Look at the examples that we've done. What's 12 times 0.5? 6. What's 6 times 1.5? 9. Yeah, that's the little formula. Your whole life you've measured angles in degrees. Anybody know what a degree is?
How big the small angle is.
Okay. But if I say 1 degree, what does that mean? It's a totally made up, totally random, leftover from the old Egyptian days. A degree is 1/360th of a revolution. Nothing mathematical about it, it's totally made up. The ancients could have said it was 1/300th or 1/5. They chose 360 because they were fascinated by 6s and 12s and all that. Degrees are split up into smaller pieces called minutes and seconds. A minute is 1/60th of a degree. So think about an hour on think about an hour on a regular clock. The whole thing around, that's 1 hour. But that hour is split up into 60 smaller pieces, and those are called minutes. Likewise, a degree is split up into 60 little pieces called minutes. And then the minutes are split up into seconds. So it is exactly like a clock. If you've ever watched a show, a movie or something, where they were like sailing in a ship and they had to give their latitude or longitude, they will often say things like, 83 degrees, 10 minutes. Because these subdivide degrees. So if we want to be accurate on a globe, we have to break down those degrees into smaller pieces. All right, so we got our definitions. Everybody okay with that? All right, let's start doing some problems now. Check attendance real quick. Wait, this is C. Okay, Emma, Katie, you said was sick. Beatrice? Where's Beatrice? Kendall's here, Eli's here, Alexander?
Here.
Jake's here, Paige?
Here.
Abe's here, Max Goodburn? Meg, Ian?
Yeah.
Who's Ian? You? Jaden's here, Amanda, Kara, Van, Peter, Braden, Kamara, Drew, Robbie. He's supposed to be here, he's just absent. Jackson's here, Nyla's here, and Sydney's here. Perfect. Okay. All right, let's start doing some problems then. Convert from degrees, minutes, seconds, that's what DMS stands for. Convert from degrees, minutes, seconds to decimal form. Now, you guys were so lucky because when I learned this when I was your age, I had to do it all by hand and it was so tedious. You got a button on your calculator that'll do it for you. So here's what we're gonna do. Get your calculator out. This is 136 degrees, 10 minutes, and 14 seconds. So would you all agree that my answer is gonna be 136 point something? Because it's 136 whole degrees, and then some fractional pieces. Step one, go to mode, look where I'm pointing, you know where your mode button is. Make sure your calculator's set in degrees. So go down and highlight degrees. Okay? Now, I'm gonna type this in on my calculator, it's real easy. Type in 136, just that part, 136. Now, look where I'm pointing. My finger is on, for me it's purple, it says apps. But right above apps, it says angle. So second apps will bring up your angle menu, right? What's the very first thing in that list? A degree mark, press it, press it. So now your calculator says 136 degrees, okay? Now type 10, go back to second angle, and what's right under the degree mark? The minute mark, so press that one. All right, now I'm gonna blow your mind. This is so weird. Press 14. I don't know if you paid any attention, but the seconds weren't in that list. When you second angle, there's no seconds in that list. You know why? Because your seconds is above your plus sign. I told you that would blow your mind, but you see it?
Yeah.
Above your plus sign. So you alpha plus. It's, for me, it's green. When it's green, I know it. You gotta press your alpha button. Did everybody find it?
Yeah.
And that brings it, then press enter. And your decimal is 136.171. I'll just round it off randomly. It doesn't say how to round, so I'll just round it off. Okay? All right, one more, same thing. So see if you can do this by yourself. Start with the 93. Anybody got it? What'd you get? 93.275. Yeah, 93.275. Okay, so those of you, go through it one more time in case you're a little bit lost. To put degrees, minutes, seconds into your calculator, you type in your degree number, go to second angle, degrees. Then type in your minute number, second angle, go down to minutes. And then type in your seconds number, alpha plus, and then equals, and that gives you. All right, everybody okay with that? All right, now we're gonna go the other way. Now we're gonna take a decimal, 103.74, and we're gonna change it into 103 degrees, some minutes, and some seconds. We're gonna find the minutes and the seconds that go with that particular decimal. All right, so type in the number, the whole thing, 103.74, whoops, 103.74. Go back into your angle menu. So second angle, and you see in the list where it says DMS? That's degrees, minutes, seconds. So just go down and click DMS and press enter. And this one is 103 degrees, 44 minutes, and 24 seconds. Agreed? All right, do the next one. 18.77. What'd you get? 18 degrees?
46, 12 seconds.
Yep. All right, so we just practiced changing from a decimal into degrees, minutes, seconds, and from changing degrees, minutes, seconds into a decimal. Okay. Well, now we're going to change from degrees into radians. Now be careful. When it says exact, anytime, whether it's this kind of problem, anytime in math class, that it says exact, that means no calculator. That means you're going to leave things like pi, and you're going to leave things like a square root. No decimals, no rounding off. We're going to do this totally by hand. So, 70 degrees is how many radians? That's our question. Now, this is not fair of me because I haven't given you the conversion. You know, like 12 inches is 1 foot. I haven't given you the conversion, so I'm going to give it to you right now. Pi radians is 180 degrees. See this entire packet that I gave you of notes? That idea is going to come up over and over again. Pi radians is 180 degrees. So the question is, okay, pi radians is 180. How many radians is 70? There are different ways to do that, kids, but one very obvious way is to set up a proportion. Look at that proportion for a minute and see if that makes sense to you. Aren't these two equal? Pi radians is 180 degrees. So I want to know what makes this equal. So pi over 180 equals x over 70. So 180x equals 70 pi. And x equals 70 pi over 180, which reduces to 7 pi over 18. Could we do that thing with any angle I gave you? Yeah, what if it's 15 degrees? No big deal, right? Now, one caution. When this I'm always going to put pi over 180. That's my relationship. But does it make sense to you then, if this is pi over 180, that this one has to be x over 70? Yes, because 180 is the degree measure and 70 is the degree measure. And they have to both be in the same spot in the fraction. So don't use 70 over x. All right, do 120. See if you can do 120 degrees. How many radians are 120 degrees? You'll always get a fraction. Make sure you reduce it. What'd you come up with? What'd you get? 2/3 pi. You can write that 2 pi over 3, or you can write it 2/3 pi. Whatever you're comfortable with, that is exactly right. Anybody not get that? Everybody got that? Okay. All right, now, same directions. Convert to radians, but this time you can use your calculator. Okay? So what do you think we're going to do with 73/12? Change it to a decimal. Very good. So 73/12, dig back in your memory from 5 minutes ago, change this into a decimal. What is it in a decimal?
73.2.
73.2. Everybody get that?
Yeah.
Okay, now, can we set up a similar proportion? Can we say pi is to 180 as something is to 73.2?
Yeah.
And cross multiply. And this time though, we're not gonna leave our answer as this fraction. We're gonna go ahead and type it in. Now, some of you may have different ways of doing this, and I'm okay with however you do it on the calculator. It's perfectly fine. The answer needs to come out to be what? Anybody get an answer?
1.2776.
Okay, yep, we'll go with that. 1.2776. So, if you did something different, particularly like if you're coming out of another teacher's class, if you did something different, it's okay. Just make sure you're getting this as your answer. Okay? All right, would you do the next one, 4B? See what you get for 4B. Anybody get something? Okay. Running off the 1,000, yep. Anybody not get that? Alright, now we're going the other way. Oops. Now we've got a radian measure. This is no calculator. No calculator for number 5. I didn't say that, but no calculator. We're changing 9 pi over 10 into a radian measure. Now there's a hard way and an easy way to do this, you guys. I want you to think about something for a second. What's pi? Pi radians is how many degrees? 180. So isn't this right here 180? Don't I just want to take 9/10 of 180? Isn't that what I've got here?
Yeah.
So 9/10 of 180. Oh, that arithmetic's gonna drive some of you crazy. So go ahead and use your calculator to help you with that arithmetic. Because I don't want anybody stressing out. You get 162 degrees.
Yeah.
Remember, a whole pi is 180. The next problem is not a whole pi, it's 7/9 of a pi. So what's 7/9 of 180? 140. Perfect. Perfect. Uh-oh. What's different about C? That is 3 radians, and we're changing it into degrees. What's different about it? There's no pi. Any thought on that? How we might do it? Oh. Okay, let's go back to a couple minutes ago. Remember when we set up a portion and said pi is to 180? What would go over here in this problem? This is pi radians and 180 degrees. So what am I gonna put over here? 3 radians and x degrees? Eli, you wait over there? So pi radians is always 180. Question is, 3 radians is what? The answer is 540 divided by pi degrees. Don't mess with it. That's the degree measure. Whatever x came out to be, that is the degree measure. Next problem, last one in this set. Pi is to 180 as what? What's going to be the second half of my proportion? 1.6 is to x. Is everybody clear why he put the 1.6 on top? Yeah, because it's a radian measure, so it's got to go up there with the radian. Yep, perfect. All right, I'm going to leave this exact so I can use my calculator to multiply. So I got 288 equals pi x, 288 over pi degrees. Okay, just a little bit more. Hang on. Just a little bit more. Let's stop there and recap anything. Is there anything you need to go back and pick up? I'm not done. Put that calculator away. All right, here we go. Number 6. I have an arc of a circle. So right here, this is my arc. And it has a length of 7. The angle measure is 100 degrees. And I want to know the radius of the circle. That's 100 degrees. And that's the problem, isn't it? Because what's our formula for arc length? Look back, I had you write it down. Radius times radians. Now my radius, my arc length is 7. My radius is r. but my angle is 100 degrees, and I need it to be in radians. So what am I going to have to do? Convert it. And I know how to do that because I just practiced. Pi is to 180 as something is to 100. Pi radians is 180 degrees. So how many radians are 100 degrees? Did you get 5 pi over 9?
Yeah.
Now this happens a lot. We get so excited, we did all this work, we got 5 pi over 9, and we write it in the answer blank. But that isn't the answer. What's 5 pi over 9? That's the radian measure of the angle. So arc length equals radius times radians. You're solving for R. You want to get R by itself. Any ideas? What? So divide both sides by 5 pi over 9. Now I'm okay with that as long as you remember how to deal with this. 7 divided by 5 pi over 9 is 7 times 9 over 5 pi. So I got 63 over 5 pi equals R. Now I'm telling you, you're going to get crazy answers over and over again. Don't panic about it. That's it. Another way you could have done this is times both sides by 9 and then divide by 5 if you didn't want to mess with the fraction.
Do you ever want us to like reduce it all the way?
You mean get a
Like-
decimal for it?
Yeah.
Well, the directions would say something like round to the nearest hundredth or something like that. Then you would type in it. All right, one more problem and then I'll stop, okay? One more. Letter B. What is the perimeter of a 10-degree sector cut from a circular disc with a radius of 11? Okay, can you draw that picture? Here's your circular disc. The radius is 11. And we have a 10-degree sector. And we want to know the perimeter of that sector. Now, vocabulary-wise, a sector is a piece of pie. So we're talking about this piece of pie right here, and your job is to find the perimeter of it. Now, what do we know already? We know that's 11, and that one's also 11. So basically, all we have to find is our arc length, right? And how do we find arc length? Arc length equals radius times radians, but oh shoot, that angle is in degrees. So pi is to 180 as something is to 10. So we're going to change that into a radian measure. Oh, that's not right. Did you get 1/18?
Yeah.
Pi? So radius is 11. Radians is pi over 18. Did you get 11 pi over 18 for your arc length? Radius times radians?
Yeah.
So you want perimeter now. So the perimeter is a radius and another radius and an arc length. So 22 plus 11 pi over 18. And that's enough for today. By the way, the unit on that would be inches, because the radius was inches, so the perimeter will be inches. All right, good work, people. Way to go.